What if I told you there's a place on Earth where you can drive above the clouds, where the ground disappears beneath you, and for a few surreal minutes, it feels like your car is floating in the sky? Not a simulation, not a movie scene, this is real. And by the end of this story, you'll understand exactly how engineers pulled off something so outrageous that for years, experts believed it simply couldn't be done. Imagine standing at the edge of a massive gorge, wind roaring past your ears, looking down into a drop so deep your eyes struggle to find the bottom. Now imagine someone telling you that a bridge, an actual highway, will stretch across that void, hanging 565 meters above the river below. That's taller than the Eiffel Tower. That's high enough that clouds drift beneath your feet. And somehow, every day, people casually drive across it like it's just another road. Before this bridge existed, crossing this region was a completely different story. The journey wasn't just inconvenient, it was exhausting. Twisting mountain roads forced travelers into a 5-hour ordeal just to get from one side of the gorge to the other. Sharp turns, dangerous cliffs, unpredictable weather. It was the kind of route that tested patience and nerves every single time. For millions of people living in the region, this wasn't an occasional inconvenience, it was daily life. This part of China had long been one of the most isolated areas on the planet. Entire communities were effectively cut off from fast transportation. No major highways connected them efficiently. In fact, until the year 2000, there wasn't even a proper expressway running through the province. For a country rapidly modernizing, that kind of isolation wasn't just a logistical problem, it was a barrier to economic growth, opportunity, and connection. So the government made a bold decision. No matter the cost, no matter the difficulty, this region would be connected. Roads would be built, infrastructure would reach even the most remote areas. But there was one obstacle that kept shutting down every plan, one massive gorge that refused to cooperate. For over a decade, engineers tried to solve it. Different bridge designs were proposed, analyzed, and ultimately rejected. Traditional suspension bridges? Not feasible. Arch bridges? Structurally impossible at that scale and terrain. Every concept that worked elsewhere failed here. The gorge was simply too extreme, too wide, too deep, too exposed to violent winds. Before any construction could even be considered, engineers spent 2 full years studying the environment. They measured wind speeds, analyzed geological stability, and ran countless simulations. The data they collected was intimidating. Wind gusts in the gorge could reach up to 140 kilometers per hour. That kind of force doesn't just shake structures, it tears them apart if they're not perfectly designed. For years, it seemed like the gorge would remain unconquered. Then, in 2011, everything changed. One engineer came forward with a design that didn't try to fight the environment, but work with it. Instead of relying on traditional methods, the proposal introduced a cable-stayed bridge supported by towers anchored directly into the cliff edges. It was a radical idea, risky, complex, but for the first time, it seemed possible. Construction officially began in November 2011, and almost immediately, reality hit hard. The first question people often ask is simple. How do you even start building something like this? There were no easy access points, no flat ground, no space for heavy machinery. Workers had to reach areas that were practically vertical rock faces, and yet every anchor point had to be drilled deep into solid stone to ensure stability. Machines couldn't do most of this work, there simply wasn't room. So much of the early construction relied on human effort, workers physically drilling into rock, securing foundations piece by piece. Even moving equipment across the gorge was a challenge. Traditional cranes couldn't span the distance, so engineers had to design a completely new system, a cable network stretched across the gap, acting as a temporary transport line for tools, materials, and components. But before any of that could function, they had to create access. That meant carving a road directly into the cliff. Using around 200 carefully controlled explosions, teams blasted away sections of rock to form a narrow construction path. Each blast had to be perfectly calculated. Too much force and the surrounding rock could become unstable. Too little and progress would stall. After every explosion, geologists examined the remaining surface in extreme detail, checking for cracks or weaknesses that could compromise the entire project. Once access was secured, the real work began. Two separate teams started building from opposite sides of the gorge simultaneously. It was the only way to keep the project on schedule. Each side worked independently, yet everything had to align perfectly in the end. The foundations were critical. Each anchor point was drilled 15 meters deep into solid bedrock. No shortcuts, no compromises. These anchors would ultimately hold tens of thousands of tons suspended in mid-air. There was zero margin for error. After 8 months of relentless effort, the foundation pits were finally ready for concrete. And this wasn't a simple pour. Each tower base required about 15,000 cubic meters of concrete, poured continuously without stopping. If the process paused midway, the structure could develop weak points, tiny imperfections that might one day lead to a catastrophic failure. So once the pour began, it didn't stop until it was complete. Inside that massive volume of concrete was a dense network of steel reinforcement, so tightly packed that moving through it was almost impossible. From there, the towers began to rise. Unlike most structures, these towers weren't built on flat ground. They grew directly from the edges of cliffs. Engineers used a self-climbing formwork system that allowed the structure to rise steadily, about 4 meters every day. Safety was a constant concern. At those heights, with powerful winds sweeping through the gorge, even a small mistake could be fatal. So every working platform was enclosed, protecting workers from sudden gusts. Despite the conditions, progress was astonishing. One tower reached 100 meters in just 62 days. Precision was everything. Every meter added required laser measurements to ensure perfect vertical alignment. Even a slight deviation could compromise the entire structure. Meanwhile, the team on the opposite side was advancing even faster, at one point getting 40 meters ahead. Winter brought freezing temperatures, but construction didn't stop. Inside the towers, pre-stressed cables were embedded within the concrete, strengthening the structure and allowing it to handle immense forces. After 18 months, both towers stood complete, 392 meters tall, rising from the cliffs like giants. And yet, the gorge between them was still empty. The next phase was even more complex, installing the cables that would support the bridge deck. Each tower would hold 56 cables, and every cable consisted of 109 individual steel wires bundled together. These cables would carry the weight of the entire bridge, transferring it down into the foundations. To begin, a helicopter was used to carry the first thin line across the gorge, a distance of 720 meters. The pilot had to hover in strong crosswinds while workers secured the line. It was a moment that demanded incredible precision and nerve. From that first line, thicker cables were gradually installed. But this wasn't just about placing cables, it was about balance. Every new cable affected the tension of all the others. Engineers had to adjust and fine-tune constantly, like tuning a massive musical instrument. As more cables were added, the structure began to take shape, resembling a giant harp stretched across the sky. Then a new problem emerged. The wind caused the cables to vibrate, producing a low, eerie sound. But it wasn't just noise, it was dangerous. Continuous vibration could weaken the steel over time, leading to potential failure. Engineers had to act fast. Their solution was to install viscous dampers inside each cable system, devices that absorbed movement and stabilized the structure. Once installed, the vibrations dropped dramatically and the cables became steady. With all 112 cables in place, the bridge was finally ready for the next stage, the deck. Construction started from both towers, extending outward towards the center. Each segment of the deck was prefabricated elsewhere and then transported into position. Working 565 meters above the ground, crews assembled each segment with extreme care. Every bolt was tightened to exact specifications, every weld was inspected. As the two sides grew closer, tension increased, not just in the structure, but among the engineers. When the gap between the two halves narrowed, measurements revealed something alarming. They were misaligned by 3 centimeters. At that scale, even a small misalignment is a huge problem. But But instead of tearing anything down, engineers made micro-adjustments to the tension in specific cables. Over 18 hours, they carefully shifted the structure millimeter by millimeter until the alignment was nearly perfect. The final gap was reduced to just 2 millimeters. Then came the final piece, a 120-ton segment that had to fit perfectly into place. When it was lowered and secured, the two halves of the bridge became one. For the first time in history, the gorge was fully crossed. From there, the remaining work moved quickly. Concrete paving was completed in just 6 continuous days. Safety systems, lighting, and markings were installed. The bridge was equipped with hundreds of sensors constantly monitoring its condition, tracking stress, movement, and environmental factors in real time. Testing began soon after. Dozens of fully loaded trucks drove onto the bridge simultaneously. Engineers measured how much it bent under the weight, just 45 millimeters, exactly as predicted. Every test confirmed what simulations had already shown.
Finally, after years of effort, inspections, and verification, the bridge was ready. On December 29, 2016, it officially opened. The first vehicles crossed in just 4 minutes, a journey that once took 5 hours. For the people who had lived in isolation for generations, the impact was immediate and emotional. Travel became faster, safer, and easier. Businesses transformed overnight. Entire communities were suddenly connected to the rest of the country. And for a moment, as lights illuminated the structure stretching across the darkness, it felt like something more than just a bridge had been built. It was proof. Proof that even in the face of impossible terrain, brutal weather, and years of failed attempts, human determination can still find a way. Because sometimes, when people say something can't be built, that's exactly when it gets built anyway.